This is Covalent Molecules. It's Chapter 23, Section 5 of your book. The first thing I want to do is give you some definitions so that we're all on the same page when we use these words. The first definition is compound. A compound is a bond, whether it's ionic or covalent, between different types of atoms. For example, NaCl is a bond between sodium and chlorine, or H2O is a bond between hydrogen and oxygen, but not O2, which would be a bond between two oxygens, or O3, which would be a bond between three oxygens. The second definition I want to give you is molecule. A molecule is any covalently bonded atoms. So in this case, we're only talking about covalent bonds, not ionic. For example, H2O is covalently bonded, or O2 or O3. And I know you don't quite know what that means yet, but not NaCl. You should know by now that NaCl, sodium chloride, is ionic. Sodium is the positive ion, chlorine is the negative ion. There's an electrical attraction between them. And another way you can look at that is sodium is a metal, chlorine is a nonmetal. Generally speaking, ionic bonds happen between metals and nonmetals. So that's kind of a little trick. A covalent molecule, then, is bonds between nonmetals. So there's no metals in a covalent bond, in which electrons are shared between atoms to achieve full valence shells. Instead of electrons transferring to get positive or negative charges and then electrically attracting, the atoms share electrons between them to get a full valence shell, which would be 8 electrons, of course, except hydrogen and helium, in which it's 2 electrons, because remember, those only fill up the first smallest energy level. Let's take a look at some examples. One thing to keep in mind is in each covalent bond, 2 electrons are shared. So I'm going to show you 3 different types of covalent bonds, if you will. The first type is called a single bond. In a single bond, 2 electrons are shared. So here's an example of that. We have hydrogen with its 1 valence electron and chlorine with 7 valence electrons. So if hydrogen and chlorine share these 2 electrons, then sometimes hydrogen has the 2 it needs, and sometimes chlorine has the 8 it needs, and therefore by sharing those, they each have a full valence shell. Remember that when you share something, neither one nor the other has it completely, and that's something you know if you share a sandwich with somebody, everybody gets part of the sandwich. So let's look at how you would actually write that bond. You would have your hydrogen, and you would have your chlorine. And between them then, you draw just one line, and that one line stands for the 2 electrons that are shared. And then you go ahead and you put in chlorine's extra unbonded electrons. And that's what those are called, unbonded electrons. And so that's how you would draw hydrogen bonded to chlorine covalently. Let's take a look now at a double bond. Sometimes atoms will share more than 2 electrons. They might share 4 electrons, double the single bond. So let's take a look at an example like that. So here we have 2 oxygen atoms. Each one has 6 valence electrons, meaning if they just shared these 2, they would only each have 7 valence electrons. So instead, they also share those. And therefore, by sharing 4 electrons, each one sometimes has 8 valence electrons. And we draw that like this. So there's one oxygen. There's the other oxygen. And then we draw, in this case, 2 lines between. That line didn't come out very well. 2 lines between, and then add in 1, 2, 3, 4, and 1, 2, 3, 4. So now you can see, remember, each bond, each line is 2 electrons. So the oxygen has, each oxygen has 8 electrons, because these 4 in the middle that are the bonding 4 right here, those 4 count for each oxygen. There's a third type, and that is, as you may have predicted, what's called a triple bond. Sometimes it's not enough just to share 4 electrons. You need to share 6. So an example of that is nitrogen. Nitrogen, each nitrogen has 5 valence electrons, and therefore it can share these 2, and these 2, and these 2, sharing a total of 6. And so then we would write that as nitrogen and nitrogen, and there'd be 3 lines, meaning 6 are shared, so each nitrogen has full claim over those 6, or part claim over those 6, and then 2 unbonded each, which makes a total of 8. Besides the differences we've already seen between covalent and ionic bonds, such as in ionic bonds it's an electrical attraction, in covalent bonds they're sharing electrons, ionic bonds are metal to nonmetal, covalent bonds are nonmetal to metal, nonmetal to nonmetal, ionic are nonmetal to metal. There's another major difference, and that is, because electrons are shared, you can actually have different molecules using the same types of atoms. Covalent bonds tend to be a little more flexible in their configuration. And when I say flexible, I don't mean there are lots of options for one molecule per se, but that you could have H2O, which would be a bond between 2 hydrogens and 1 oxygen, and you could have H2O2, which is a bond between 2 hydrogens and 2 oxygens. H2O being water, we all know what water is, H2O2 being hydrogen peroxide, which is that bubbly stuff that you might put on your cuts so that they don't get infected and it bubbles away. That's H2O2, hydrogen peroxide. So let me show you how that works. So I'm going to show this with the molecules having certain shapes. Don't worry right now about the shapes. You'll learn a little bit about that later. So for example, on the left I have H2O. So we can see that we could have a bond here and we could have a bond there. Then each hydrogen has 2 electrons and the oxygen ends up with 8 electrons. Or in the example of H2O2, we could have our bond here, we could have our bond there, and then we could have our bond there. And so that's H2O2. Same atoms, but because they're sharing electrons differently, they become 2 completely different molecules that may have some properties in common, but also may not have properties in common. And you'll see that when we study covalent molecules. Something like sugars, there's different kinds of sugars, lactose, sucrose, glucose, and they're essentially combinations of hydrogens and carbons and oxygens in different ratios.